Good evening, everyone. I am Sangeetha B from the Department of CSE IoT, working in a SNS College of Engineering, Coimbatore. In last video, we have discussed about the embedded system and what are all the things we are using in embedded system and why we are using the embedded system. And in this video, we are going to see about the architecture of the embedded system. The first point of the architecture of first, what is an embedded system? The embedded system is a combination of a hardware where we are using to automate a things or automated things. For a embedded system, architecture refers to the fundamental structure and a design of an embedded system, which plays a vital role in determining its performance, capability, and suitability for the specific application. The typical embedded system mainly has its two-point embedded hardware and an embedded software. For example, embedded hardware depends upon purely the microprocessor and the microcontroller, where the embedded software is a programming language. We use the embedded C or a Python. Let's see detailed about it. Embedded hardwares are based around microprocessor and the microcontroller. Also include memory, bus, input output controller, whereas embedded software includes embedded operating system, different applications, and a device type. um, Memory, which is used to store the data which is coming from the microprocessor and the microcontroller. Bus, where we uses to order our task. Input output, where we get our output. Controller, all these are included in the embedded hardware. In embedded software, operating systems like Linux, Windows, and different application and device drivers. Basically, two types of architecture, Harvard architecture and non-Neumann architecture, are used in the embedded system. Architecture of the embedded system includes sensor, analog to digital converter, memory, processor, digital to analog converter, and the actuators. The sensor is basically we use it in an automation. Next, the converters, memory, processor, etc. Now let's see the overview of the architecture of an embedded system. This is the diagram where first thing is in software we have an application and an embedded microprocessor, and in the next hardware we have an embedded OS and the peripheral device where we give the input and we get the output. The next one is let's see overview. Microcontroller versus microprocessor. Microcontroller are integrated circuits that combine a processor core, memory, and the input-output peripherals into a single chip. They are commonly used in the embedded system due to their compactness and the cost effectiveness. Microprocessor, on the other hand, are a standalone processing unit without integrated peripherals. They are typically used in more complex embedded systems where customization and the performance are essential. Memory architecture. Embedded systems often have a limited memory resources. Understanding the memory heritage, including RAM, that is random access memory, and the ROM, read-only memory, is crucial for efficient programming to execute and the data storage. Flash memory is commonly used for non-volatile storage of a program code and the data in the embedded system. Next one is Harvard versus non-Neumann architecture. Embedded system may employ either the Harvard or a non-Neumann architecture. Harvard architecture has a separate memory space for programming instruction and the data, which allows for simultaneously fetching of the instruction and the data. This can improve execution speed but may require additional hardware. Non-Neumann architecture uses a single memory space for both programming instruction and the data. While it is simpler, it can result in the slower execution. Single core versus multi-core processor. The choice between single core and the multi-core processor depends upon the performance requirement of the embedded system. Single core processor are suitable for simple tasks and the application with the low process demand. Multi-core processor can handle parallel processing, making them ideal for the application requiring multitask or the real-time processing. Next one is bus architecture. The bus architecture defines how the data and the control signals are transferred between different components of the embedded system, including the CPU, memory, and the peripheral. Understanding the bus architecture is crucial for optimizing the data transfer rate and minimizing the bottleneck. Next one is system on chip. Refers to the compact design where all necessary components of the embedded system, including CPU, memory, and the peripherals, are integrated onto a single chip. Are commonly used in modern embedded systems, reducing the overall size, power consumption, and the cost. So, thank you. Have a nice day.